Hello friends, in this video today we are going to discuss about normalization of wave function. Normalization of wave function. Suppose we have a wave function which is a function of position and time. It must be a solution of the Schrodinger equation, that is I h del psi by del t is equal to h square minus by twice m del 2 psi by del x2 plus v into psi. So it must be a solution of this equation. Now you see, if this wave function is a solution of this equation, and if we multiply a constant with this wave function, suppose a psi xt, so if a is a constant, and if this function is a solution of this Schrodinger equation, then this must be also a solution of this Schrodinger equation, is also a solution of this, suppose equation number 1, solution of 1. Okay, and here you see, if this function, it is a solution of psi xt, it is a solution of this Schrodinger equation, it also satisfies this condition minus infinity to plus infinity psi x and t mod square dx is equal to 1. And hence here you see, we need to find a value of this a, we need to find such a value of a so that it also satisfies this condition. Okay, it also satisfies this condition, and this process is called normalizing the wave function. So hope you have understood this. Now let me give you an example for that. To explain the process of normalization, let me take a problem here. Suppose this is a wave function that is given here, and we need to normalize this wave function psi. And also, as I have already shown in the previous video, in the first video of this quantum mechanics series, how to find expectation values, and this also, and sigma square also, how to sketch the graph, and we will solve those also here. So now first let me show you how to normalize the psi. Okay, let me scroll down the page. So first let me write the given wave function. So what is the wave function given here? So this is the given wave function psi. It is a function of position and time, that is equal to a e to the power minus lambda mod x into e to the power minus I omega t. Okay, I omega t. So here you see, what is the normalization condition? So that is minus infinity to plus infinity, and here is the term that probability density. This represents probability density. So in the previous problem we have used rho of x, and same thing represents here. So now you see, into dx is equal to 1. This is the normalization condition. So here you can see, now mod of psi square, what does it mean? Mod of psi means, mod of psi, we know psi is a complex quantity, so it must be equal to psi star, that means complex conjugate of psi into psi. Okay, so hope you have understood this. Then in that case, if you find psi star, if this is psi is this, then what will be psi star? Psi star will be a e to the power minus lambda mod of x, then e to the power, here it will be plus I omega t. It must be complex conjugate. Here it is minus it omega t, here it is plus I omega t. If you multiply these two, then these two terms, if you multiply, then it will be e to the power 0, hence equal to 1. So we will get product of these two, that's going to be a square e to the power minus 2 lambda mod x. Okay, so that means, so instead of this we can write this term. Hope you have understood this. So let me clean this first. So it implies integration minus infinity to plus infinity. We can write the a square outside, e to the power minus 2 lambda mod of x dx is equal to 1. So we have this. So now what we're going to do here, you see this integration we can write 2 into a square, then we can make it 0 to infinity. Okay, 0 to infinity, e to the power minus 2 lambda mod of x dx is equal to 1. Now if you integrate this, then what you will get, then you're gonna have 2a square e to the power minus 2 lambda mod of x, and it is 0 to infinity divided by minus twice lambda is equal to 1. So here 2 gone, and we're gonna have here here you can see, if you put infinity here, then e to the power minus infinity, remember e to the power minus infinity, it is 0, and if you put here 0 here, then we will get e to the power 0, and that's going to be 1. So 0 minus, this term will be 0 minus 1, that's going to be minus 1, and this minus and this minus, it's going to be plus. So what we're going to have at the end, so we will get a square by lambda is equal to 1. Okay, so hope you have understood this, what we have done here. And if you simplify this, then you will get a square equal to lambda, and a is equal to root over lambda. So this is the required value of a. So that's how we can normalize the wave function psi. So now let's move on to next part of the question, that is we need to find those expectation values of x and x square. So how to find that? So here you see, in the previous video I have already explained such kind of problem, how to solve. I will provide the link in the description box. Please watch the video first. So here average of x, here average means in quantum mechanics the expectation value, here a square, then minus infinity to plus infinity x. First let me write this way. So here you can see, so how to find the expectation value. So if you remember, that's equal to minus infinity to plus infinity, here probability density square dx. Okay, and this term we have already I have already explained that that's going to be equal to a square e to the power minus 2 pi mod x. Okay, so here you see one more thing, when you find the expectation value, then there should be x. Okay, there should be x. So here if you take x here, then what will happen? It will be an odd function. Odd function means, now f of minus x, it is a function. If it is equal to f of x, then it is said to be even function. And if f of minus x is not equal to f of x, so it must be equal to minus f of x, then it is odd function. And integration of odd function is always 0. Remember that integration of odd function is always 0. If you say if you put minus 1 here, then this term will be 1. Okay, this term will be 1. If you put minus 1 here, x equal to minus 1, this result will be e to the power minus 2 lambda, and if you put plus 1 then you will get e to the power minus twice lambda, and these two are not equal. This is f of minus x and this is f of plus x. So these two are not equal, so that's why it is an odd function, and hence this must be equal to, this results must be equal to 0. So that's what we have got. Now, so what will be or how to calculate this expectation value of x square? So that's minus infinity to plus infinity x square, then probability density dx. Okay, so again what we're going to have here, a square minus infinity, if you make it 0 to infinity then there will be a 2, and x square e to the power minus 2 lambda mod x dx. Okay, so now here you see, let me show the integration part, how to integrate this. So let me show it. Now if you take the integration only 0 to infinity x square e to the power minus 2 lambda x dx, so then what you will get, consider this is first function and this is second function, first function, second function. Okay, according to ILAT, LATE. Okay, first algebraic function then exponential, so exponential algebraic function should be considered first, so here x square is considered as first function. So in that case we will get x square integration of e to lambda x dx minus integration derivative of x square, that's going to be twice x, then integration e to the power minus 2 lambda x dx and whole dx again. So if you differentiate integrate this again, here you see you will get x square e to the power minus 2 lambda x by minus twice lambda, then you will get minus 2 by minus 2 lambda. When you will integrate you will get minus twice lambda as a denominator, as it is constant I have taken out and this 2 is taken out, then you will get x e to the power minus twice lambda x dx. Okay, so here again what you are going to do, take this one as first function and this is second, then what you will get, again you have to apply the product rule. Okay, so if you use that, so here 2 to cancel. Okay, so then what you will get, x square e to the power minus 2 lambda x by minus twice lambda, here it will be plus 1 by lambda, this minus become plus. So here again first function, that is x, integration of the second e to the power minus 2 lambda x dx minus integration whole derivative of x is 1, so into e to the power integration e to the power minus 2 lambda x dx. So now what you're gonna have again, x square e to the power minus 2 lambda x by minus 2 lambda plus 1 by lambda, then you will get x, on integration you will get minus e to the power minus twice lambda x by minus 2 lambda, then minus if you integrate twice, if you integrate this, then you will get integration of this one is e to the power minus 2 lambda x by minus twice lambda, and again if you integrate this, as there is also again integration, so then it will be plus 4 lambda here. Okay, so hope you have understood this, lambda is square, not only lambda. So then, so what we have got, so we have got e to the power minus 2 lambda x by 4 lambda square. So we have got this. Now if you simplify this, here you see we can take common e to the power minus 2 lambda x by minus twice lambda, and then you will get minus x square minus x by lambda, then minus I have multiplied this one with this, then 1 by 2 lambda square, and sorry, I have taken this one as positive. Okay, then what will you get? So here you see we had a limit here 0 to infinity, so I haven't used here, so let me write here 0 to infinity. I haven't shown in all the steps, so if you put 0 to infinity, use this limit, then what will happen? Now you see, first let us put infinity, so this term gonna be 0, and 0 into anything is always 0 because it's gonna be minus infinity. E to the power minus infinity is 0, so whole thing gonna be 0. Then if you put x is equal to 0 here, then this part will be 0, sorry, not 0, this from this part you will get these two terms will be 0, you will get minus 1 by 2 lambda square, then and here you will get if you put here 0, you will get only 1 by 2 lambda, and minus when you have put this upper limit, that is lambda, then we had got 0, yes, 0 minus this thing, and that's gonna be equal to 1 by 4 lambda cube, 1 by 4 lambda cube. So that is the value. So here you see, then as I have already shown you that this is what, this is nothing but 0 to infinity 0 to infinity twice a square e to the power minus, sorry, not only this one, x square e to the power minus 2 lambda x dx. This is equal to this, but that's we have got. Now expectation value of this x square is given by, I have already told you that a square minus infinity to plus infinity x square e to the power minus 2 pi x dx, isn't it? So we have made it 0, then here 2 should be there, and we have already got this value of a square here above. Here you can see we have already found it, a square, this is a square. Now put this a square here, use this a square value, that is lambda. So if you use this lambda here, and this value of this integration is this, now if you put here 1 by 4 lambda cube, then what you're gonna have, then you're gonna have 1 by 2 lambda square, 1 by 2 lambda square. So this is it. Okay, so now what is the task next job we have to do here? So we need to find sigma square. Now we need to find sigma square. So how to find that expectation value of x square minus square of the expectation value of x? So we have already found this, that is 1 by 2 lambda square, and expectation value of x is 0 and 0 square is 0, so it's gonna be 1 by 2 lambda square. So hope you have understood this. Now what we're gonna do, our next task is to find draw the graph of this. This is the position, and we need to draw the graph of this mod of psi square. Okay, so we need to draw this graph. So how to draw this graph? Now you see we have got mod of psi x whole square, that's equal to a square e to the power minus 2 pi mod of x. So how it gonna be happen, I have already explained you, and a square is lambda here, e to the power minus 2 lambda, okay, mod of x. And for plus sigma and towards minus sigma, how it will vary? So in this case if you see, so x plus minus mod of sigma here, mod of psi plus minus sigma here square, that's going to be what, lambda e to the power minus 2 lambda. So it doesn't matter if you put here plus sigma or minus sigma, it is always going to be sigma. So, and we have got that sigma square is, what is the sigma square? This is the value of sigma square, isn't it? Sigma square. So that, therefore sigma will be root over 2 into lambda. So that's going to be sigma. So if you put here lambda e to the power minus 2 lambda divided by root 2 lambda, then you will get e to the power minus root 2, that is approximately equal to 0.24 lambda. It is approximately equal to this value. So if you use calculator, you will get this value, okay, this one. So here you see, when the value of this psi will be maximum when x is equal to 0. When x is equal to 0, then e to the power 0 is 1. 1 into a square is a square. A square is nothing but lambda. So that is the maximum value. Then if you put any other value, positive or negative, here e to the power negative of something, that's going to be always decreasing here. So then we will get such kind of graph, okay, this kind of graph we will get. And this value here, you see, this value 0.24 lambda must be lying somewhere this point, 0.24 into lambda, so somewhere this. So this is the graph we were asked to draw. And also we need to find a probability of the particle that could be found outside the range, outside this range. So what will be the probability of this outside the, outside it? So how to find the probability? So here you see, so this point is origin O, where x is equal to 0, and here you see, as e to the power minus 2 pi lambda, this is mod x. So if you put minus x or plus x, it doesn't matter, its value, this value will be always positive, and hence the power, the exponent on e, it is always remains negative. 2 pi, it's going to be minus 2 pi, sorry, not pi, lambda x. So e to the power minus something is always going to be very small values, but it's never going to be equal to 0. So that's why this is the required graph. So let me first find the probability towards this side, outside this positive sigma range. So then what will happen? Integration 0 to not 0, sigma to infinity, then the probability density, that means psi x psi x comma t mod of square of mod this dx. So this is given, this gives the probability. Then the probability of getting the particle on this side, outside this minus sigma to infinity, between this range minus sigma to minus infinity, that will be also same. So total probability outside this range we can consider 2 into this, okay, 2 into this integration. So if you consider that, then what will happen? This is nothing but sigma. So this is 2 and its value is nothing but a square. So here sigma to infinity a square e to the power minus 2 lambda mod of x dx, okay. So mod of x dx, you can say. Then a square we have already got, that is lambda, okay. So if you integrate this, then you will get e to the power minus twice lambda mod of x by 2 minus 2 lambda, you get this, and from 0 to infinity, not 0, sigma to infinity. Okay, sigma to infinity. So if you put here infinity, then e to the power minus infinity is 0, so that's going to be 0. So from this, if you evaluate this, then you will get here you see this sigma is 2, this 2 gone, so you will get 0 minus, and if you put sigma here, then you will get e to the power minus 2 into lambda sigma. Okay, you will get this. So we have got the value of this. Also one more thing, there is minus sign, so it will be plus. Okay, it will be plus. So here you see, then it will be e to the power minus 2 lambda, and sigma is nothing but root 2, 1 by root 2 into lambda. So if you cancel this, then you will get minus e to the power minus root 2, and that is approximately equal to 0.2431. So that's how we can solve this. So hope you have understood this problem, how to solve this problem. For better understanding, please watch the previous video on quantum mechanics that I have uploaded, and the link is given in the description box. And if you like this and if you have understood, then please share with your friends and subscribe my channel if you are new to my channel. Okay, thank you.